Have you ever wondered why time always flows forward and never backward? It's a question that has puzzled philosophers, scientists, and thinkers for centuries. Welcome to the fascinating exploration of the arrow of time, the directional asymmetry of time, which is the grand stage on which our universe unfolds. We'll start with the basics. The idea of time's arrow, or the arrow of time, is a concept that has been used to explain why we perceive time to move in one direction, from the past, through the present, and into the future. It's a concept that's deeply ingrained in our human experience and one that has profound implications for our understanding of the universe. Throughout this video, we will delve into 10 compelling theories about the arrow of time. We'll explore ideas from the realm of thermodynamics, where the arrow of time is linked to entropy and the second law of thermodynamics. We'll venture into the cosmos, where the cosmological arrow of time points in the direction of our universe's expansion. We'll even dip our toes into the quantum realm, where the rules of time seem to get a bit, well, peculiar. From there, we'll examine the psychological arrow of time, the way our brains perceive the passage of time. And finally, we'll consider other intriguing theories that push the boundaries of our current understanding. Each theory offers a unique perspective, a different lens through which to view the enigma of time. Some theories align with our everyday experiences, while others challenge our intuitive understanding of the world. But all of them contribute to the ongoing scientific dialogue about the nature of time and the universe. The arrow of time is a concept that is both deeply familiar and profoundly mysterious. It's a journey through the familiar corridors of our everyday experience and into the farthest reaches of the cosmos. It's a voyage that promises to challenge our assumptions, expand our understanding, and ignite our curiosity. So, buckle up for a fascinating ride through the landscape of time. Let's dive into the intriguing world of time and its mysteries. Our first theory revolves around the laws of thermodynamics. Imagine a cup of hot coffee sitting on your kitchen table. Over time, it cools down, right? It doesn't spontaneously heat up. This everyday observation is actually a profound insight into the nature of time, all thanks to the second law of thermodynamics. The second law of thermodynamics is a fundamental principle of physics. It states that in a closed system, entropy or disorder always increases. Picture a child's bedroom. Left to its own devices, it tends to become more and more disorganized, not less. It's the same with our universe. Given enough time, things naturally progress from order to disorder, from low entropy to high entropy. So what does this have to do with the arrow of time? Well, if you think about it, this law introduces a directionality to time. A broken glass doesn't spontaneously unshatter and leap back onto the table. An ice cube doesn't unmelt and reform in your drink. These are examples of increasing entropy, and they always occur in one direction, forward in time. But here's where things get really interesting. If you were to watch a video of these processes happening in reverse, it would seem odd, wouldn't it? That's because our universe has a preference for increasing entropy. It's as if time itself is threaded through the very fabric of reality, always moving from past to future, from order to disorder. This brings us to the concept of the thermodynamic arrow of time. It's the idea that the direction of time is dictated by the increase in entropy. It's why we remember yesterday and not tomorrow, why we grow old, why stars burn out and galaxies fade. So could the answer to the arrow of time lie in the realm of thermodynamics? Let's explore further. Another theory takes us to the vast cosmos and the Big Bang. As we venture into the universe's expanse, we encounter the cosmological arrow of time. This theory points in the direction of the universe's expansion, a journey that began with the birth of the universe, the Big Bang. Now, imagine time as an arrow shot from the cosmic bow of the Big Bang. As the arrow soars, it charts the expansion of the universe. Galaxies drift apart, stars ignite and extinguish, and cosmic structures evolve. All of these events serve as cosmic breadcrumbs, marking the path of the cosmological arrow of time. The theory of the cosmological arrow of time suggests that time's direction is intimately tied to the universe's expansion. As the universe expands, time moves forward. The universe's evolution from a hot, dense state to the current cool, diffuse one mirrors the one-way flow of time we experience. But what happens if the universe starts contracting? Some cosmologists suggest that if the universe were to begin contracting, leading to a big crunch, the arrow of time might reverse. In this scenario, broken cups would spontaneously assemble themselves, and we'd remember the future instead of the past. It's a mind-bending concept, isn't it? However, it's worth noting that the current cosmological evidence points towards an ever-accelerating expansion of the universe, not a contraction. If this continues, the cosmological arrow of time will keep pointing in the same direction, aligning with our everyday experience of time. In the cosmological perspective, the arrow of time emerges from the universe's evolution. It's a grand cosmic explanation, connecting the flow of time to the destiny of the universe itself. Nevertheless, it's just one piece of the puzzle in our quest to understand the nature of time. Is the answer to the arrow of time written in the stars? Or perhaps it's in the quantum world? As we continue our journey, let's dive into the strange and fascinating realm of quantum mechanics to explore another perspective on the arrow of time. Quantum mechanics also has something to say about the arrow of time. Quantum mechanics, the theory that describes the strange world of atoms and subatomic particles, introduces its own concept of the arrow of time. This is known as the quantum mechanical arrow of time. Unlike the thermodynamic and cosmological arrows of time, which are largely based on the principles of entropy and the expansion of the universe, the quantum mechanical arrow of time has a different basis. It's all about entanglement. Quantum entanglement, to be precise. Let's dive a bit deeper, shall we? Quantum entanglement is a phenomenon where two particles become linked, and the state of one immediately influences the state of the other, no matter how far apart they are. Einstein famously called it spooky action at a distance. This entanglement suggests a direction for time, as one particle knows the state of the other before any observable interaction occurs. This leads us to the quantum mechanical arrow of time. You see, the moment these particles become entangled, they share a past, but their futures are not entangled, suggesting a direction for time from the shared past towards the unentangled future. The quantum mechanical arrow of time is unique because it doesn't rely on the concept of entropy or the expansion of the universe. Instead, it's based on the fundamental principles of quantum mechanics. It's a different approach, one that's still being explored and understood. This quantum perspective of time is intriguing. It introduces a new way to think about the flow of time, one that's independent of the traditional thermodynamic and cosmological perspectives. It might be strange and, yes, a little spooky, but it's also incredibly fascinating. As we delve deeper into the quantum world, we continue to uncover more about the nature of time itself. And who knows? Quantum mechanics might just hold the key to finally understanding why time flows in one direction and not the other. Quantum mechanics might seem strange, but it could hold the key to understanding the arrow of time. Our perception of time also plays a crucial role. As we delve into the psychological arrow of time, we find that our understanding of time's passage is intimately tied to our memories and consciousness. Now, this is fascinating. Instead of a physical arrow, we're dealing with a subjective one. Imagine this. You're sitting in a quiet room, lost in thought. Suddenly, a minute feels like an eternity. Yet when you're having a blast with friends, hours can feel like fleeting moments. This is the psychological arrow of time at work. It's our minds that are dictating the flow, speed, and direction of time. It's an intricate dance between our experiences and how we perceive them. Our memories, both past and present, shape our perception of time's passage. It's a unique, personal journey that each of us embarks on. It seems time's arrow might be as much in our minds as in the physical world. There are many more theories about the arrow of time. In the vast expanse of our universe, the arrow of time flies straight, never veering off its path. Let's delve into some other theories that attempt to explain this fascinating phenomenon. One such theory is the radiative arrow of time. This theory, rooted in the field of electromagnetism, suggests that the arrow of time moves in the direction of radiation. It's like a cosmic lighthouse, with its light always beaming outward, never inward. This theory, though less explored, offers a unique perspective on the flow of time. Then there's the causal arrow of time, which is grounded in the concept of causality. It proposes that cause and effect define the direction of time. In other words, an effect can never precede its cause. A dropped glass will shatter on the floor, but the shards won't spontaneously assemble and leap back onto the table. This theory is fundamental to our understanding of physical laws and the universe's behavior. But here's the kicker. These theories about the arrow of time are not mutually exclusive. They can coexist, each providing a different lens to view the same phenomenon. They're like pieces of a cosmic puzzle, each essential to the complete picture. This coexistence suggests that our understanding of time is multifaceted, and we're just scratching the surface. So, what does this all mean? Well, it means that the arrow of time is a complex concept that can't be pinned down to a single explanation. The universe is a grand tapestry, woven with threads of different theories, all intertwining to form the fabric of our understanding. The arrow of time remains a mystery, pointing us towards the future and leaving the past behind. But as we continue to explore and understand, who knows what we might discover next? As we journey through this cosmic odyssey, let's keep our minds open to the infinite possibilities that await us. After all, the arrow of time never stops, and neither should our quest for knowledge. Before we wrap up our cosmic journey, we'd love for you to join the conversation. If you've learned something new from this video, then please give it a like. Your likes help us reach more curious minds, just like yours. Share your thoughts and opinions in the comments section. Do you have a favorite theory about the arrow of time? Or perhaps you have a theory of your own? We'd love to hear from you. Don't forget to subscribe and press the bell icon to stay updated on our latest videos. We regularly explore fascinating topics like this one, and we wouldn't want you to miss out. Remember, knowledge grows when shared, so don't hesitate to share this video with your friends and family. Who knows? You might inspire a future scientist or philosopher in your midst. So, as we continue to unravel the mysteries of the universe, let's do it together as a community of lifelong learners. Remember, the arrow of time never stops, and neither should our quest for knowledge.